So let's talk about the information that one can obtain from a chemical formula. So when we write a chemical formula, obviously we use the symbols for the particular elements that are in that chemical compound. The order in which those symbols for the elements are written, we'll talk about in another video. Right now, I just want to introduce the fact that the letters in a chemical formula represent symbols for the elements in that chemical formula. And to determine or to show the number of that particular atom in the formula, we use subscripts. So this little number down below. So subscripts tell us the number of atoms for each element. If there is no subscript for a particular element, then that means you just have one of that element. So for example, for good old H2O, water, that subscript 2 for hydrogen tells me that in water I have 2 hydrogen atoms. There's no subscript for oxygen, but that's all right because that's an implied 1 that tells me I have 1 oxygen atom in this water molecule. And those subscripts are super important because they tell us, obviously, the number of atoms for each element. And they also are important because, if you change the subscript for an element in a particular formula, then you completely change the identity of that molecule. So CO, carbon monoxide, 1 oxygen, behaves a lot differently than carbon dioxide. So keeping track of your subscripts, writing correct subscripts for chemical formulas is going to be really important because the identity of that molecule is determined not only by the elements that are present, but by using the appropriate subscript. Oh, so I was wrong. We are going to talk about, in this video, the order in which elements are written in a chemical formula. How did I know to write hydrogen first and then water second, and then oxygen second? So when writing chemical formulas, to determine the order of the elements written, you first need to know if the chemical formula contains metals and nonmetals or just contains nonmetals. And so here's where your knowledge from chapter 4 is going to come into play again. You need to remember, okay, what elements are metals and what are nonmetals? You'll always have the periodic table in front of you to use for quizzes and exams and your notes. So you should know that metals are on the left-hand side of the periodic table and in the middle. Nonmetals are on the right. So NaCl, KBr, Al2S3, these are all compounds that contain metals and nonmetals. And so if you have an ionic compound, that's something that contains a metal and a nonmetal, the metal is always written first. So that's why in NaCl, the sodium comes first because that is the metal. So far and so forth with KBr and Al2S3. These are ionic compounds. They contain metals and nonmetals. The metal is written first. For those molecules that are just nonmetals, they only contain nonmetals. And if you remember from chapter 3, those are called molecular compounds because they have covalent bonds. If you have a compound that contains only nonmetals, the rule is that the element that is closest to the metal is usually written first. The one exception to that is with hydrogen, because we have hydrogen in group 1, so you would think hydrogen's written first, but really carbon is. So for example, with PCl3, both of these are nonmetals, as seen on the periodic table. Phosphorus is closer to the metals than chlorine, so phosphorus comes first. Okay? So for compounds containing only nonmetals or molecular compounds, element that is closest to the metals in the periodic table is listed first, usually. So in those examples, we looked at compounds that had monoatomic species, meaning just sodium or potassium. There are species that are called polyatomic ions. Now, ions, that's something that you should remember from chapter 4, ions or species that have a charge associated with them. Polyatomic ions can make up chemical formulas as well. We're going to talk about them in detail. But these polyatomic ions, they are a group of atoms and they act as a unit. They work together, and they have a charge associated with them because that's the definition of ion. So I like to think of polyatomic ions. Well, actually, I got this idea from Dr. Zappala. Think of polyatomic ions as groupies. They work as a unit. They hang out together. One such polyatomic ion is NO3 negative. And that negative charge comes along with the entire NO3. So that is the entire polyatomic ion. So with polyatomic ions, you just need to be a little bit more careful in looking at subscripts and when determining number and type of atom that are present. So in this particular chemical formula, I have Mg, NO3 in parentheses and then 2. Now, why we write this compound this way, we'll talk about a little later, but you should look at this and be able to say, oh, I see from this chemical formula, I have 1 magnesium ion. How many NO3s do I have? Well, I have 2 of them. That 2 goes to everything that's within the brackets, in the parentheses. I have 2 NO3s. If I wanted to know how many nitrogens, how many N atoms were in this species, well, that N is part of this, is in this parentheses, so that 2 has to go inside. So you can think about as there's 2 nitrogens, and then if I asked for how many oxygens, you would say 3 times 2 or 6. So we're going to do some more practice with this in a little bit later. Take-home message from this slide is that many chemical formulas will sometimes use what are called polyatomic ions. One such example is NO3 negative 1. They act as a group, they're groupies, and they travel as a unit. So what I just talked about in the previous slide is kind of written here as to determining number of type of atom in that species. So if we were to do something similar with these 3 molecules, if I was to ask what type of atom is each, you should be able to use those subscripts and the rules that we talked about to determine that. So for this first molecule, I see I have the calcium with an implied 1, so I've got 1 calcium. That chlorine is in the parentheses with the 2, so that 2 comes in. I have 2 chlorines, and then oxygens would be 4 times 2 or 8. Then I can do similar type of process with these other 2 molecules. So I would try practicing some of the examples that are on the Canvas worksheet, where I give you a molecule and you have to determine the number of type of atom in each of the following species.